right, we're asked to find a couple of probabilities regarding a normal distribution that has a mean of 58 and a standard deviation of 9. So of course, we're going to start by defining our normal dist 58, comma 9. And the first question asks us to find the probability that a single randomly selected value from this distribution is between 56 and 58. So that's an X probability. And we can see that in the probability statement here, the probability that an X value is between 56 and 58. Since that's a between probability, in the cumulative probability dropdown in Desmos, I've defined my distribution with the appropriate mean and standard deviation. And I'm looking for an area. So I want to compute an area. So I'm just going to change the X values for the probability statement to 56, less than or equal to X, less than or equal to 58, and it gives me the area, but be careful, I want my answer to 4 decimal places, so I can just click on the arrow to drop open a view that gives me 4 decimal places, and then enter that value. All right, so that's part A. Part A was asking about a single randomly selected value. Now let's look at part B. Part B wants me to find the probability that a randomly selected sample of 75 observations has a mean between 56 and 58. So it's not asking about an X probability. It's asking me about an X bar probability. So let's go over here to Desmos. I'm going to keep my original normal dist here. In fact, I can just remind myself that that's my underlying distribution, and then I'm going to duplicate it and call it S for the sampling distribution. So what do I have to change for the sampling distribution? We know that the sampling distribution of the sample mean, provided that we have either a large sample size, which we have here, or if we don't have a large sample size, we must know that our underlying population is normally distributed. And so we also have that here. So we check either box here. So we know the sampling distribution is normally distributed, and the mean of the sampling distribution by the central limit theorem is the mean of the underlying distribution. So I'm not going to change that. The mean is still 58, but the standard deviation is much smaller for the sampling distribution with a sample size of 75. This standard error of the mean, which is the standard deviation of the sampling distribution, is the standard deviation of the underlying distribution, that's the 9, sigma equals 9, divided by the square root of the sample size, which is 75. So that's going to be a much smaller standard deviation. And by the way, we can see that if we click over here to view the distributions. So the red distribution is my sampling distribution of the sample mean. The purple distribution is the underlying distribution. And so if you sort of look at them both together, you can see that the X distribution is much flatter. It's much more spread out because it has a much higher standard deviation. All right, so the values here are the same values that I was looking for in part A, so I don't need to change those. This says X in the middle, but that's just because Desmos doesn't know that this distribution is actually our sampling distribution, but we know it is, so we know that this is really finding the probability related to X bar. And so again, I can pop open the value to get 4 decimal places for that result, and I get 0.4729. So as you would expect, and as we can see from the difference in the distribution shapes of the sampling distribution versus the underlying X distribution, we would expect this to be a much bigger probability because the sampling distribution is so much more compressed over that mean.